Hello everybody. Once again I am here with you for the another session of this optics and lasers, and we are looking for the Rayling's criteria. So Rayling's is the who have given the criteria for separating the two spectras from each other, and what is to be resolved the things or the images from, or the bright sharp images from each other, or the spectras are separated which are very close to each other with the central bright maxima. We can differentiate either it is resolved or not resolved. So the Ranning's criteria is basically for the resolving the two images from each other, or the two bright points from each other. And this simple criteria is that if the two nearby images are said to be resolved, if the position of the central bright maxima of the first of the one coincides with the first secondary minima of the other, or vice versa. So the things are very simple, and these are the central bright maxima for the image A and the B. Spectral tool spectral lines maximas are there, and having the wavelength lambda 1 and lambda 2. Now in this first diagram, we can say as a 5a, or given figure name as an here. If you look at this stage where the peak for the A is and the B is well separated from the each other, and there is no overlapping of this central maxima for the A to the minima of the first. It is well separated. They are not like nearer to each other. They are well separated. These bright maximas are there, and due to that, the whatever be the A and B, the central maximum of the diffraction pattern of the two spectral lines of the wavelength lambda 1 and lambda 2. The angle of diffraction corresponding to the central maximum of the image B is greater than image A, and hence the two spectral lines are said to be well resolved. And if you look at for the second case, here if you look at these central bright maximas for the closer next to closer maxima, that is A is having the wavelength lambda, and the next wavelength, that is lambda plus d lambda, and A and B are such a very close to each other, and it looks like to be as a single peak. And that's why the single maxim bright maxima, it looks like to be a one, not a two separate maxima peaks are there. And when the central maxima of the two wavelengths lambda and lambda plus d lambda are very close, and look likes to be as an one maxima as an C. And in this case, it is the case of the for the spectral line, that is to be as in two spectral lines are not resolved. When it looks like to be as in one peak and they are very close to each other, in such condition we can say the such images or the spectra are not resolved. Now here is the another third case where which gives you the resolving things from each other. If you look at this stage where the central bright maxima of the A is overlapping here with the minima of the another first minima of the another spectra. Similarly, vice versa, minima of this A spectra is going to be overlapped or at the B's central bright maxima. म्हणजे A चा सेंट्रल ब्राईट मॅक्सिमा हा पीक बीच्या फर्स्ट मिनिमावर, आणि बीचा सेंट्रल ब्राईट मॅक्सिमा एच्या फर्स्ट मिनिमावर, अशा पद्धतीने जेव्हा ओव्हरलॅपिंग होते, that is nothing but to be called as a just resolved condition. Where if you look at the another case where the C is to be as a deep structure, C जे आहे ते एक deep structure आहे, आणि ते इंडिकेट करायला की they are little bit separated, not completely separated, but at they are starting to be as an separation level. So this deep like a C here in this diagram 5C is for the wavelength lambda and the lambda plus d lambda. It is showing the condition for these two spectra as a just resolved condition. and this is how the way where we can separate the two bright maxima of the spectral lines from each other. So this is what the Rayling's criteria. Thank you for joining this session. Be at home and be safe. Thank you.